here, and hopefully it'll pick up the rest of the way. All right, but good. Thank you for letting me know. All right. So the next one says f of -7 if f of w is equal to 16 plus 3w minus w squared. And you're like, oh, what's the deal with this w business? We will be using different variables to represent different things. We just did it in the last problem. C represented cost, and it took on the role of x in the problem. So here we have w instead of x. So maybe w represents weight or water pressure or something that starts with the letter w. All right, but it still boils down the same way, where we would say f of -7 instead of the w, and then we'd go ahead and replace all the w's with -7s. All right. In Desmos, you can still do it with the w's if you want. I'll show you. You can say f of w is equal to 16 plus 3w minus w squared. Right? And it's gonna essentially treat the w as if it's an x. The only thing with Desmos that you might run into an issue with is sometimes there's letters that are reserved as variables. So if you try to use them, Desmos gets confused. But you could also have just written this with x's instead of w's, right? And then type in f of -7, and you get -54, which is what you would get if you simplify this. This, so let me turn my pen on. 16 for quality equal sign. 16, 3 times 7, -7 is -21. Minus -7 squared is -7 times -7, which is positive 49. But that negative on the outside comes along for the ride. So 16 minus 21 is -5. -5 minus 49 is -54. It's just you're able to save yourself a little bit of time and energy if you become a little bit more proficient with Desmos, right? So just when I sell you on Desmos, I switch it up, and now it's saying find g of m if g of x is equal to this. 2x to the 6th minus 10x to the 4th, and so on. And you look at it and say, all right, I was with you, but now what the hell do I do? You do the same thing, except you can't use Desmos for this. All right, it's an algebraic process. So, except you don't really have to do too much, because the variable here is x. The process of evaluating a function tells us to replace all the x's with whatever is contained within the expression that's telling you to evaluate in the first place. So we want to replace all those x's with n's, right? So when we evaluated the previous function, when x is -7, we replaced all the x's with -7s. So how's this any different? Instead of saying x being replaced with a -7, we're saying x being replaced with an m. All right. Now this is the first step toward what's called composition of functions or composing functions. The idea is that, and this is kind of a weird thing to think about, but m might be a placeholder for another function. There might be another function out there called m that's represented algebraically. Like, we don't know this, but maybe m is equal to x squared plus 5. So this is a shorthand way of saying we're going to put one function inside of another function. All right. So when you look at number 5, oh, that's it for number 4, by the way. There's nothing else to do. When you look at number 5, though, it's telling us we have this function in terms of x. All right, let's go ahead and replace all those x's with the w plus 2. So rewrite the function. And again, if this said k of, let's say it's a k of -7, you'd know what to do. You'd put the -7 in each of the places where the x's were. All right. This time it says w plus 2. So I'm going to take that w plus 2 that was here. I'm going to take that and plug it in for each one of these x's. So here and here.
Hey, Professor, real quick,
Sure.
why did you why'd you pick W plus 2?
Oh, it's not a matter of picking it. That's what they told us to substitute in.
Oh,
So they,
okay. Now I see the if in front of K. All right. Sorry about
yeah.
that.
Oh, yeah, not a problem. So now we have this expression. And again, just going back to what I wrote before, I'm going to take this jammy here, copy and bring it down. The left-hand side is notation. All right. So this is saying function K evaluated when x is, I mean, it's not just a simple number anymore, when x is equal to w plus 2. So what we're saying is that there's an additional relationship. Like we have this function that says k of x is equal to 3x plus 4. Now I'm telling you what x is. X is equal to w plus 2. So it makes sense that you would now be able to substitute and replace every single x with a w plus 2. All right. These aren't questions where we're required to simplify, but if we were, you would distribute and then combine like terms. Now, something to keep in mind, just the procedural thing when it comes to taking a test. If a question does not tell you to simplify, very important, folks, do not simplify. It's not a question of like, oh, I have the option. It's more like, you better not simplify. So if the question tells you to simplify, you absolutely must simplify. But if it doesn't tell you to simplify, then don't, right? And the reason why is it has to do with credit, right? Anything that you put on paper or put as part of a solution, anything that you include, you're presenting for evaluation. So even if it's irrelevant to the problem, if I look at your work and I see something incorrect, I have to take off credit for it. All right. So what I'm telling you is it's kind of like the worst feeling in the world when you lose credit for something that didn't have to be there to begin with. So if I say simplify, you need to simplify, but if I don't. All right. Don't get ambitious. Don't think, oh, I'm sure it'll look much nicer if I simplify. There is a reason why I'm not telling you to simplify. So please just take that into account when you're coming up with your solution. All right. So in this case, the directions, you just kind of look at it. At the top, it actually did say to simplify. So we would have had to do it if my marker worked here. We would have had to do it in this situation, but if it didn't say simplify, you would just leave it at this. All right. So the next one, h of a minus 2, if h of x is equal to, that trinomial 2x squared minus x plus 3. So I'm going to rewrite. The value or well, normally it would be a value, but in this case, it's an expression. They're telling us that x is the same as a minus 2. So everywhere I have an x, I'm going to replace it with an a minus 2. All right. And then because the directions told us to simplify, we will. So it's good practice anyway, but the left-hand side is just their notation. We don't have to worry about that. All right. Think of it as sort of like a command. This is the command, and this is us executing that command. All right. So a minus 2 squared, very, very important. When you actually raise that to the second power, you need to distribute a minus 2 times a minus 2. All right. And I'm just going to put it off on the side here. A minus 2 squared is not the same as a squared plus 4. All right. Not the same. Because what people will do, just as a bad habit, force of habit, they'll take the a and square it. They'll be like, oh, okay, I'm squaring it. Let me square this guy right there. Let me square this guy right there. Hey, that wasn't so bad. That's not how it works. All right. If there's multiple terms within an expression, you have to use a distributive property, right? Some kind of distributive property. Sometimes it's this, FOIL method, double distributing, and sometimes it's simpler or more complicated, but you still have to do it. All right. So I'm going to bring down the 2. Right at this moment here, I see that I have a -1. I just tucked a little 1 in there. I'm going to distribute that to each term just kind of on the fly. -1 times a is negative a. -1 times -2 is positive 2. And then we have the +3. All right. So we can simplify a little bit around that binomial squared, but we eventually have to tackle this. So let's do it now. A times a is a squared. A times -2 is -2a. -2 times a, -2a. -2 times -2 is positive 4. But don't forget that whole thing is getting multiplied by the 2 in the front. And then you have all this stuff at the end here, -a plus 5. So a little bit more distributing. I'm just going to kind of smidge it down a little bit so I can make my arcs. The 2 is going to get run through. Well, actually, I could combine those terms first. It really doesn't matter. It's going to be commutative, but I might as well combine them first. So 2 times a squared minus 4a plus 4 minus a plus 5. So now I'll run through with the 2. So 2a squared minus 8a plus 8 minus a plus 5. Then I can combine some terms, some like terms, and be done with it. And I'll use my highlighter here. I got a -8a and a -1a. There's nothing like the 2a squared, so I'll leave that as is. 2a squared minus 9a. And then I have the 8 and the 5, which is going to give me a 13, so positive 13. So all of these lines of expression are equivalent to this command here telling us to evaluate h for a minus 2. But the simplest form would be the 2a squared minus 9a plus 13. All right. So that was fun. Let me stop this recording. We're going to do